Saturn, the sixth planet from the Sun, is a celestial wonder. Its most captivating feature is its rings, a dazzling display of ice and rock that stretches thousands of miles wide. These rings, visible even with a small telescope, have inspired awe and wonder for centuries. However, this breathtaking sight is not permanent. The rings of Saturn, as we know them, are slowly disappearing. This vanishing act has captivated scientists and stargazers alike, prompting us to understand the forces at play in this celestial ballet. The disappearance of Saturn's rings is not a random occurrence but a predictable event driven by powerful cosmic forces. In the vast expanse of space, Saturn's rings face a relentless barrage of cosmic particles and radiation. This constant bombardment, while seemingly insignificant at first glance, takes a toll over eons. The very same gravity that holds the rings in orbit around Saturn also contributes to their demise. This gravitational pull draws them inward, causing them to slowly rain down onto the planet's surface. This intricate dance of gravity and matter is a testament to the interconnectedness of the cosmos. The rings of Saturn, while seemingly eternal, are engaged in a slow but steady march towards their demise. Scientists estimate that these magnificent structures will vanish in approximately 100 million years. This process of ring rain is driven by the relentless tug of Saturn's gravity. Like a celestial vacuum cleaner, the planet slowly draws in the particles that make up its rings. The innermost rings, being closer to Saturn, are expected to vanish first. The ice particles, being less dense, are more susceptible to Saturn's gravitational pull and are therefore disappearing at a faster rate than the heavier rock and dust particles. The disappearance of Saturn's rings is not a unique event. Astronomers believe that Saturn's rings are not a permanent fixture, but rather a transient phenomenon, constantly being replenished and depleted over millions of years. One theory suggests that the rings are formed from the remnants of comets, asteroids, or even moons that have strayed too close to Saturn and been torn apart by its powerful gravity. These celestial objects, upon their destruction, provide fresh material that replenishes the rings. Another possibility is that the rings are formed from material ejected from Saturn's moons. This interplay between Saturn and its moons creates a dynamic and ever-changing environment, constantly shaping and reshaping the planet's iconic ring system. While 100 million years might seem like an incredibly long time for the rings to disappear completely, it's important to remember that this is just an estimate. The actual lifespan of Saturn's rings could be shorter or longer depending on a variety of factors. The study of Saturn's rings is a dynamic field, and scientists are constantly making new discoveries that challenge our understanding of these celestial structures. As we continue to observe and study Saturn's rings, we can expect to refine our estimates of their lifespan and gain a deeper understanding of the complex interplay of forces that govern their fate. In the vast expanse of space, gravity reigns supreme, an invisible force shaping the cosmos. Saturn's rings, those magnificent structures of ice and rock, are no exception to gravity's powerful grip. They are held in orbit by Saturn's gravitational pull, a delicate balance between inertia and attraction. This balance is not static, it's a dynamic dance, with gravity constantly shaping and reshaping the rings over millions of years. The closer a ring particle is to Saturn, the stronger the gravitational force it experiences. This differential rotation, while seemingly subtle, has profound implications for the structure and evolution of Saturn's rings. It creates shear forces within the rings, causing collisions between ring particles. These collisions, occurring at high speeds, can chip away at the ice and rock, grinding them down into smaller and smaller pieces. Over time, this process contributes to the gradual erosion of the rings. The composition of the rings also plays a crucial role in their evolution. The icy nature of Saturn's rings makes them particularly susceptible to erosion, contributing to their relatively short lifespan on a cosmic scale. The slow demise of Saturn's rings is not a silent process. As ring particles rain down onto the planet, they interact with Saturn's atmosphere, creating faint but detectable signals. These signals, like whispers from space, provide scientists with valuable clues about the composition and dynamics of both the rings and the planet's upper atmosphere. One way scientists study these signals is by observing Saturn in ultraviolet light. As ring particles enter the upper atmosphere, they interact with hydrogen atoms, absorbing ultraviolet radiation. This absorption creates dark bands in Saturn's ultraviolet spectrum, revealing the rate at which ring material is being deposited onto the planet. The ongoing disappearance of Saturn's rings presents a unique opportunity for scientists to study planetary ring systems in unprecedented detail. The Cassini spacecraft, which orbited Saturn for over a decade, provided a wealth of data about the rings, revealing their intricate structure, composition, and dynamics. Cassini's instruments allowed scientists to study the rings in various wavelengths of light, revealing details that would be impossible to observe from Earth. Future missions to Saturn, equipped with even more advanced instruments, will continue to unravel the mysteries of these enigmatic structures. The gradual disappearance of Saturn's rings presents a unique opportunity for scientists. It's like having a front-row seat to a cosmic experiment, a chance to observe and study the processes that shape planetary ring systems throughout the universe. One of the key areas of research focuses on the dynamics of ring systems. By studying how Saturn's rings are evolving, we can gain a deeper understanding of the forces that govern their behavior. This includes the gravitational interactions between the rings, Saturn and its moons, as well as the collisions between ring particles that drive their erosion and evolution. By analyzing the light that passes through the rings or is reflected from them, scientists can determine the size, shape, and composition of the ring particles. The phenomenon of ring rain, the steady flow of ring particles onto Saturn's atmosphere, offers a unique opportunity to study the composition of both the rings and the planet's upper atmosphere. By analyzing the light emitted by these particles as they interact with Saturn's atmosphere, scientists can identify the chemical elements present in the rings. This information can help us understand the conditions under which the rings formed and evolved. Furthermore, studying ring rain can help us understand the complex processes that govern planetary atmospheres. By studying these interactions, we can gain a better understanding of atmospheric dynamics and chemistry, not just on Saturn, but on other planets as well. The rings of Saturn are not just a beautiful spectacle, they are also a time capsule, preserving clues about the planet's distant past. By studying the composition and structure of the rings, scientists can piece together a history of Saturn and its surrounding environment. The presence of certain isotopes in the ring particles can provide information about the conditions in the early solar system when Saturn formed. The size distribution of the ring particles can tell us about the history of collisions and accretion that shaped the rings over time. Some scientists believe that the rings may be the remnants of a moon that was torn apart by Saturn's gravity. By studying the composition of the rings and comparing it to the moon's, we can test these hypotheses and learn more about the complex interplay between Saturn and its satellites. The study of Saturn's vanishing rings holds implications far beyond this one planet. The lessons we learn from this cosmic laboratory can be applied to other ring systems in our solar system and beyond. By comparing and contrasting different ring systems, we can gain a more comprehensive understanding of the factors that influence their formation, evolution, and eventual demise. Understanding ring systems can provide insights into the formation and evolution of planetary systems as a whole. By studying these rings, we can learn more about the conditions under which planets form and the processes that shape their early evolution. In the grand scheme of the cosmos, where time is measured in billions of years, even the most awe-inspiring celestial structures are ephemeral. Saturn's rings, those magnificent bands of ice and rock, are no exception. While their disappearance may seem like a distant event, a mere whisper in the cosmic timescale, it serves as a poignant reminder of the transient nature of all things, even in the vastness of space. The eventual fate of Saturn's rings is inextricably linked to the fate of Saturn itself. As the Sun ages, it will eventually exhaust its nuclear fuel and enter its red giant phase. Even if Saturn escapes the Sun's fiery embrace, the rings are still destined to fade away. While the precise timeline for the disappearance of Saturn's rings remains uncertain, scientists estimate that they could vanish completely within the next 100 million to a billion years. This may seem like an eternity, but it is a mere blink of an eye in the context of cosmic history. Imagine the entire lifespan of the Earth from its formation to the present day, compressed into a single year. On this scale, the remaining lifespan of Saturn's rings would be equivalent to just a few days or weeks. This rapid pace of change highlights the dynamic nature of our universe. Celestial objects are not static entities frozen in time. Instead, they are constantly evolving, shaped by a complex interplay of forces over vast stretches of time. The rings of Saturn, once thought to be a permanent fixture, are now understood to be a transient phenomenon, a fleeting moment in the planet's long and storied history. The study of Saturn's rings and their eventual demise provides valuable insights into the processes that govern the evolution of planetary systems throughout the universe. By observing these processes in action, we can refine our models of planetary formation and evolution, gaining a deeper understanding of the forces that shape the cosmos. Although the rings of Saturn may one day vanish from our view, their legacy will live on in the form of countless tiny particles scattered throughout the solar system. These particles, remnants of the once mighty rings, will continue to orbit the Sun, interacting with other celestial objects and potentially even seeding the formation of new planets and moons in the distant future. Some of these particles may eventually find their way to Earth, raining down as micrometeorites. These tiny messengers from Saturn would carry with them a record of the planet's history, encoded in their composition and structure. Scientists could then study these micrometeorites to learn more about the conditions in the early solar system and the processes that led to the formation of Saturn's magnificent rings. Even in their absence, the rings of Saturn will continue to inspire awe and wonder, serving as a reminder of the beauty and grandeur of the universe. Their story, a tale of creation, evolution, and eventual demise, highlights the interconnectedness of all things in the cosmos, from the smallest dust grain to the largest galaxy. The vanishing rings of Saturn, a spectacle unfolding over millions of years, offer a profound cosmic perspective. They remind us that even the most seemingly permanent celestial structures are in a constant state of flux, subject to the relentless forces of gravity, time, and cosmic events. While the eventual demise of the rings may seem like a loss, it is also a testament to the dynamic and ever-changing nature of our universe. The study of Saturn's rings has provided scientists with a wealth of knowledge, not only about planetary ring systems, but also about the processes that govern the formation and evolution of planets, moons, and solar systems. The ongoing observations of ring rain, the analysis of ring particle composition, and the study of the gravitational interplay between Saturn and its rings have significantly advanced our understanding of these celestial objects. The lessons learned from Saturn's rings extend far beyond this one planet. They provide insights into the workings of other ring systems in our solar system and beyond, offering clues about the formation and evolution of planetary systems throughout the universe. The study of Saturn's rings, therefore, is not just about understanding one celestial object. It's about unraveling the grand tapestry of the cosmos. As we ponder the fleeting beauty of Saturn's rings, we are reminded of our own place in the vast expanse of the cosmos. Our planet, our solar system, and even our galaxy are all part of this grand cosmic dance, subject to the same forces that shape the destiny of Saturn's rings. The study of such celestial phenomena fosters a sense of wonder and curiosity, pushing us to ask fundamental questions about the universe and our place within it. It reminds us that we are part of something much larger than ourselves, a cosmic story that has been unfolding for billions of years and will continue long after we are gone. The vanishing rings of Saturn serve as a poignant reminder of the importance of scientific exploration and discovery. By studying the cosmos, we not only gain a deeper understanding of the universe, but also gain a greater appreciation for the preciousness and fragility of our own planet. As we continue to explore the cosmos, we can look forward to new discoveries that will further illuminate our place in the universe and inspire future generations to unravel the mysteries of the cosmos.